Solve the simultaneous equations for x and y. 7x plus 2y equals negative 3 and x minus 3y equals 16. We can solve a pair of linear simultaneous equations by elimination or by substitution. We are firstly going to look at the method of elimination. Our first step is to make the coefficients of x or the coefficients of y the same. This means that we want the same number in front of both x terms or both y terms. We could multiply equation 2 by 7, as both coefficients of x would then be 7. However, in this case, we are going to multiply the top equation by 3 and the bottom equation by 2. Multiplying the top equation by 3 gives us 21x plus 6y equals negative 9. And multiplying the second equation by 2 gives us 2x minus 6y equals 32. As the signs in front of the 6y's are different, we're going to add the two equations. 6y plus minus 6y is equal to 0. Adding the x terms gives us 23x, as 21x plus 2x is 23x. Negative 9 plus 32 is equal to 23. Dividing both sides of this equation by 23 gives us a value of x equal to 1. We now need to substitute x equals 1 back into one of the original equations, either equation 1 or equation 2. In this case, we're going to substitute x equals 1 into equation 1. This gives us 7 multiplied by 1 plus 2y equals negative 3. Simplifying this leaves us with 7 plus 2y equals negative 3. Subtracting 7 from both sides of this equation gives us 2y equals negative 10. And finally, dividing both sides by 2 gives us a value of y equal to negative 5. This means that the solution to the simultaneous equations by elimination is x equals 1 and y equals negative 5. We are now going to look at solving the simultaneous equations by substitution. Our first step here is to make either x or y the subject of one of the equations. In this case, we're going to make x the subject of equation 2. Adding 3y to both sides of equation 2 gives us x is equal to 16 plus 3y. We now need to substitute this into equation 1. This gives us 7 multiplied by 16 plus 3y plus 2y equals negative 3. Expanding or multiplying out the brackets gives us 112 plus 21y, as 7 multiplied by 16 is 112 and 7 multiplied by 3y is 21y. Grouping our like terms gives us 112 plus 23y equals negative 3. Subtracting 112 from both sides of this equation gives us 23y equals negative 115. And finally, dividing both sides of this equation by 23 gives us an answer of y equals negative 5. We now need to substitute y equals negative 5 back into equation 3 to calculate x. X is equal to 16 plus 3 multiplied by negative 5. 3 multiplied by negative 5 is negative 15, so we are left with x equals 16 minus 15. Therefore x is equal to 1. Solving the simultaneous equations by substitution gave us the same answers, x equals 1 and y equals negative 5. We can check these answers by substituting the values into equation 1, equation 2 or equation 3.